Hey everyone, welcome back to the channel. My name is Sparks, and in today's video we are going to be talking about matrices and determinant. Now, matrices is one of the topics students find very hard to comprehend. But I promise at the end of this video we are going to decipher every mystery behind matrices. Stick to the end. Alright, so what exactly is a matrix? A matrix is an array of numbers. A matrix is an array of numbers that can be enclosed within brackets. Now, matrices are usually arranged in rows and columns. Now, this is an example of a matrix. Example of matrices. So this is an example. Let's say we have a matrix A to be equal to 1, 2, 3, and 4. This is an example of a matrix. Now, this is called the first row of the matrix, while this is the second row of the matrix. Now, this is the first column of the matrix, while this is the second column of the matrix. Now, this now brings us to a subtopic called order of matrices. Now, what exactly does the order of a matrix refer to? Now, the order of a matrix refers to the name given to that particular matrix, and it is determined by the number of rows and columns that particular matrix possesses. Now, let's come back to this example here. I drew one here. I had a matrix A to be equal to 1, 2, 3, 4. So let's say you are asked to find the order of this particular matrix. Now, the order is determined by the number of rows and columns it possesses. So now, here, this is the first row. This is the what? Second row. This is the first column. What is the what? Second column. So now, to name this matrix now, you have to call the number of rows before you call the number of columns. So now it has 2 rows. So it is a 2. Now this X is pronounced by. B-Y. By. So it is a call the number of rows before you call the number of columns. So it has 2 rows. Hence the 2 here. So that's 2 by. So it also has 2 columns. So it's a 2 by 2 matrix. So the order is determined by the number of rows and columns a particular matrix possesses. So now, let's say we have another example here. Let's say we have a matrix A to also be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now, if you are asked, what is the order of this particular matrix? Now, like I said here, you have to first identify the number of rows it has and also the number of columns it also has. So now here, it has, this is the first row, this is the second row, this is what? Third row. So we can say it has 3 rows there. So how many columns are here? So first column, second column, third column, and 4 columns. Now, to name the matrix, you have to call the number of rows before you call the number of columns. So it has 3 rows. So it is a 3. Remember, the X is called by, pronounced by. So it is a 3 by. How many columns are here? 4. So it is a 3 by 4 matrix. So finding the order of matrix is very easy. Just identify the number of rows and columns the matrix possesses. So if you know this, we can continue. So now, the next thing to do now is to find. Let us write an example here. Let us go into addition and subtraction of matrices. Now, there's a note here. Note behind. Matrices can only be added or subtracted when the are of the same order. Now, this statement says matrices can only be added or subtracted when they are of the same order. Now, what does this tell us? This tells us that you can only add a 2 by 2 matrix, for instance, to another 2 by 2 matrix. So if the orders are the same, you can add a matrix. So let us take an example of such. So here now, let's have an example on this. Example. So let's say you have a matrix A to be equal to 5, 1, 9, 7, and you have a matrix B to be equal to 7, 2, 1, 0. And you're asked to find A plus B. Now, we are given A here to be 5, 9, 1, 7, and B to be what? 7, 1, 2, 0. Now, the first thing you have to do to add or subtract is to find the order of each matrix. Check if you can actually add or subtract. So now, like this statement reads, it said, matrices can only be added or subtracted when they are of the same order. So you can never add a matrix that does not correspond to the order of the other matrix. So now here, we have 5, 9, 1, 7. So the order of what's the order of this matrix? We have, this is a 2 by 2 matrix, while this is also a 2 by 2 matrix. So going by this rule, we can add them because they are the same order. So let us add A plus B. So matrix A is 5, 1, 9, 7. So we are supposed to add it to matrix B, which is 7, 2, 1, 0. So this will in turn give us. Now, to add matrices, you have to add the corresponding elements inside the matrix. So now here will become, we are going to have, this will become 5 plus, 5 would add 7, so 5 plus 7, while 9 would add 1, so 9 plus 1. 1 will also add 2, so that is 1 plus 2, and 7 would add this, 7 plus 0. So we are going to find the total sum, which will give us 5 plus 7 gives 12, 1 plus 2 gives 3, 9 plus 1 gives 10, 7 plus 0 gives 7. So, following the rule, you can only add them if and only if they are of the same order. So you cannot add them if they are not of the same order. So you can add a 2 by 2 to another 2 by 2, 2 by 3 to another 2 by 3. You can never add a 2 by 2 to a 3 by 3 matrix. So now, let us take another example on that again. So let's say we have, going by this again, let's say we are told to find A minus B. So now, this is the matrix A, this is the matrix B. Here we're told to find A plus B, we've just done that. Now here says we should find A minus B. So now, the same rule applies. You can only add or subtract them when they are of the same order. So let us do that now. So we'll have 5, 9, 1, 7, minus 7, 1, 2, and 0. So this will give us, so remember, add or subtract them the corresponding elements. So here we'll have 5 minus 7, here we'll have 9 minus 1, here we'll have 1 minus 2, while here we'll have 7 minus 0. So this will in turn give us 5 minus 7 gives negative 2, 1 minus 2 gives negative 1, 9 minus 1 gives 8, 7 minus 0 gives 7. So this is A minus B. So working with addition and subtraction of matrices is actually very, very easy. So once you know this rule, that you can only add or subtract them when they are the same order, you are good to go. So the next thing to check is, let us go to another subtopic. So the next thing to do is multiplication of matrices. Multiplication of matrices. Now, the thing about matrices is it has a lot of rules. So once you know the rules, you are good to go. Now, the next topic is multiplication of matrices. Now, There are two types of multiplication. So there are types of multiplication. So the first one is the scalar multiplication of matrices, while the second one is the matrix multiplication. Now, what exactly is the scalar? What exactly is the matrix multiplication? Now, the thing is, the scalar multiplication of matrices involves multiplying just one number with a matrix, while the matrix multiplication involves multiplying a matrix with another matrix. Now, don't get confused. It will make sense in a minute. So let us take an example on that. So now let us take an example on, let us start with scalar multiplication of matrices. So scalar, let us start with scalar. Scalar multiplication. So I said the scalar multiplication involves multiplying a number with a matrix. So let's say we have a matrix A to be equal to 1, 2, 4, 7, 9, 6, 12, 5, and 8. And you're asked to find, let's say you're asked to find 2A. Now you're given a matrix A to be equal to 1, 7, 12, 2, 9, 5, 4, 6, and 8. And you're asked to find 2A from this. Now, normally, 2A in normal math terms means 2 multiplied by A. So now, this is an example of scalar multiplication. Why? Because I said scalar multiplication involves you multiplying a number with a particular matrix. Now, while this one involves you multiplying a matrix with another matrix. So now, we have A to be equal to this, and we're asked to find 2A from this. So 2A is simply 2 times A. So now let us do that together. So my 2A is equals to 2 multiplied by the matrix A. And the matrix A is 1, 2, 4, 7, 9, 6, 12, 5, and 8. So we are going to multiply this number with each element inside of the bracket. So 2A will be equal to, so 2 times 1 gives 2, 2 times 7 gives 14, 2 times 12 gives 24, 2 times 2 gives 4, 2 times 9 gives 18, 2 times 5 gives 10, 2 times 4 gives 8, 2 times 6 gives 12, 2 times 8 gives 16. So it is very, very easy to work with matrices. So this is an example of scalar multiplication of matrices. So let us take another example on scalar. So let's say we have a matrix A to be equal to 1, 4, 6, 5. We have a matrix B to be equal to 7, 8, 5, 9. And we are asked to find 2A plus 3B. Now this is quite different from what we did under addition and subtraction of matrices. Now, we're given A and we're given B, and we're asked to find 2A plus 3B. So now to do this now, we first have to find the value of 2A. We also have to, secondly, we have to find the value of 3B. So let us work with that now. So let us start. So we're given A to be equal to 1, 6, 4, 5, and B 7, 5, 8, 9. And we're told to find 2A plus 3B. So the first thing you do is find your what? Your 2A. So my 2A equals 2 multiplied by the matrix A. And the matrix A is 1, 6, 4, 5. So remember, multiply the number outside here with the element inside of the matrix. So this will become 2 times 1 gives 2, 2 times 4 gives 8, 2 times 6 gives 12, 2 times 5 gives 10. So my 2A is equals to this. So the next thing is to do is find your 3B. So my 3B is simply multiply my 3 with my matrix B. So that is 3, open bracket, 7, 8, 5, 9. So this will be equal to, so 3 times 7 gives 21, 3 times 8 gives 24, 3 times 5 gives 15, and 3 times 9 gives 27. Now, we are almost there. We're told to find 2a plus 3b. So, what we just done is we found the value of 2a, and we've also found the value of 3b. So, the next thing to do is to add them together. So, this is the value of 2a. So, 2a equals to this, while 3b equals to this. So, the next thing to do is add them together. So, you say your 2a plus your 3b equals, matrix 2a is 2, 12, 8, 10, plus 21, 24, 15, 27. So we have to add these two matrices together. So this will now give us 2 plus 21, right? So 12 plus 15, 8 plus 24, and 10 plus 27. So do the final sum. 2 plus 21 gives 23. This gives 32. This gives 27, while this gives 37. So it is very easy to find the scalar multiplication of matrices. So the next thing to do is your matrix multiplication. So the next thing now is the matrix multiplication. Now, I said this involves you multiplying a matrix with another matrix. Now, this is the part where students actually find a bit complex. But let us decipher that together. So now, here, there are certain rules you have to abide by to be able to multiply matrices together. So now, note behind. Says, you can only multiply two matrices if the number of elements in the first row of the first matrix is equal to the number of elements in the first column of the second matrix. So now what does all these words mean? So simply put, it is like this. So let's say I have a matrix A to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And I also have a matrix B to be equal to 1, 1, 5, 7, 6, 2. And I was asked to find, let's say you're asked to find A times B. Now the first thing you do is you check to see if you can actually multiply these matrices together. And following this rule, they said you can only multiply them if the number of elements in the first row of the first matrix is equal to the number of elements in the first column of the second matrix. Now, all these words, simply put, means, now to multiply a matrix, first check if the number of elements here, this is the first row of the first matrix. First check if the number of elements here. Now, how many elements are here? 1, 2, 3. It's actually equal to the number of elements in the first column of the second matrix. What is the first column of the second matrix? Here. So you check to see if the number of elements here is equal to the number of elements you have here. So how many elements are here? We have 1, 2, 3. So how many elements are here? 1, 2, 3. So since 3 is equal to 3, you can multiply. That is the rule. That is what all these words means. So check to see if the number of elements you have here is equal to the number of elements you have here. So now, multiplying, that is the part people find complex. But everybody watch here now. So now, there are two rules you actually have to follow before you can multiply matrices. The rules are the 7 rule and the reverse L rule. So the 7 rule and the reverse L rule. Now, we're given these two matrices. 1, 4, 7, 2, 5, 8, 3, 6, 9, this. Now we're asked to find A multiplied by B. Now I said we are going to be following two rules. The 7 rule and the reverse L rule. So now let us multiply these two matrices. You know, we've determined that we can multiply them. Because why? The number of elements you have here is equal to the number of elements you have here. So 3, 1, 2, 3 equals to 1, 2, 3. So let us multiply. So we're going to have your A times B equals, let's say we have 1, 4, 7, 2, 5, 8, 3, 6, 9, and this we have 1, 1, 5, we have 7, 6, 2. Now we have determined that we can multiply these two matrices. So let us do that together. So now the first rule you have to follow is the 7 rule, which is you multiply the elements here with the elements here. So basically, in a nutshell, the multiplying of matrices just involves you multiplying the rows with the columns. So follow the 7 rule here. So for your better understanding, just draw a 7 like this, and you multiply. Let me show you how to multiply. So you open the bracket, equals to, so open the bracket. So you have 1 times 1 plus the next thing 4 times the next element here 1 plus 7 times the next element here 7 times 5. So after you've obeyed the 7 rule, you now extend the line to the other column. So you multiply this with this, you also multiply this with this. So multiply this with the corresponding element. So you have 1 times 7 plus 4 times 6 plus 7 times 2. Now, we have obeyed the rule here, so we are not done. So the next thing to do is also multiply the second row with the columns. So you are going to multiply here with here too. So you're going to have 2 times 1 plus 5 times 1 plus 8 times 5. So you have 2 times 7 plus 5 times 6 plus 8 times 2. So now we have multiplied all that. So the next thing to do is to obey the reverse L rule, which is multiplying this element with this. So you're multiplying the last rule with the columns, so which is the reverse L rule. So we have 3 times 1 plus 6 times 1 plus 9 times 5. So also extend your line to the second column. So you're going to have 3 times 7 plus 6 times 6 plus 9 times 2. So the next thing to do is to simplify all your expressions here. So we have 1 times 1 gives 1 plus 4 times 1 gives 4 plus 7 times 5 gives 35. Now 2 times 1 gives 2 plus 5 times 1 gives 5 plus 8 times 5 gives 40. Now this gives 3 plus 6 times 1 gives 6 plus 5 times 9 gives 45. Now 1 times 7 also gives 7 plus 4 times 6 gives 28 plus 7 times 2 gives 14. So the other one also gives 14 plus 30 plus 16. This gives 21 plus 36 plus 18. Now before I do the final sum, now let's come back here for a moment. Now, after you have successfully multiplied the rows with the columns, now how you would know you're on the right path is, if you notice the trend here. We have 1 times 1, 4 times 1, 7 times 5. Now look at this side here. The pattern is, if every element here on this end aligns, we have 1, 1, 1 here, we have 1, 1, 1 here, we have 5, 5, 5 here. So if these elements here, they align, you can say you're on the right path. Also look at this, we have 7, 7, 7, we have 6, 6, 6, 2, 2, 2. So this is how you would know you're actually doing the right thing. So let us continue. Let us do the final sum now. So this will give 1 plus 4 gives 5, 5 plus 35 gives 40. Now 7 plus 28 gives 35, 35 plus 14, 35 plus 14 gives 49. Now 2 plus 5 gives 7. 7 plus 40 gives 47. 14 plus 30 gives 44. 44 plus 16 gives 60. 3 plus 6 gives 9. And 9 plus 45 gives 54. 21 plus 36 gives 37. 37 plus 18 gives 55. So this is the result of multiplying your matrix A with your matrix B. So that is multiplication deciphered. Now, let us go into another one. So we've done 2 by 2. Let us do determinant of 3 by 3 matrices. All right, so the next subtopic is determinant of 3 by 3 matrices. So let's say we have this. We have your matrix A to be equal to 1, 2, 3, 7, 2, 5, 1, 9, and 8. Now, let's say this is a matrix of what order? 3 by 3. Of 3 by, this is of what order? 3 by 3 matrix. So now, why is it a 3 by 3 matrix? Because it has 3 rows and it also has what? 3 columns. So now, let us find the determinant of this matrix together. So now, this is a little bit different from the 2 by 2 matrix determinant. Now, don't get scared. We're going to decipher it together again. So now, we have 1, 2, 3, 7, 2, 5, 1, 9, 8. So the very first step you have to take to finding the determinant of a 3 by 3 matrix is you first have to assign signs to the first row of the matrix. There are some sign conventions you have to follow to find the determinant of a 3 by 3 matrix. And what are the signs? So just assign signs to the first row of the matrix. So the signs are plus, minus, plus. That is step 1. Now after you've assigned the signs, these are the standard signs you assign. Plus, minus, plus. Now after you've assigned the signs, the next step to take is to convert your 3 by 3 matrix into 3 2 by 2 matrices. So let us do that together. So now we are going to have, so the next step is to convert this matrix into 3 2 by 2 matrices. So now how would you do that? Now the elements you assigned signs to, this plus, minus, plus you assigned. You assigned plus to 1, you assigned 7 negative, you assigned plus to this one. So now you are going to take each element out one after the other. So starting with this one, so you assigned plus to this one, so you have plus 1 into the determinant of, now 1 is on the first row, it is also on the first column. So every element on the first row and the first column will be eliminated, will go out. So the elements that are left are 2, 9, 5, 8. So now you have converted 1 into a 2 by 2 matrix. So the next thing to do is also convert. So take out the next element. You assigned 7 a negative sign. So you now have negative 7 into the determinant of. Now 7 is on this row. It is also on this column. So the elements that are not eliminated are 2, 9, 3, 8. So now the next thing is to take out the next element you assign is sign to, which is plus 1 into the determinant of. Now plus 1 is on this column, is also on this row, so the elements here will be eliminated while these ones will be written down. So we'll have 2, 2, 3, 5. So now we have successfully converted this matrix into 3 2 by 2 matrices. So let us evaluate. So we now have 1. Now, this, like I said, means determinant. So we can find the determinant of the 2. This is a 2 by 2 matrix. So we can find the determinant of this matrix by multiplying this with this. So remember, multiply the elements on the principal diagonal together. So we'll have 2 times 8 minus 5 times 9. So the next thing again, negative 7, open bracket, 2 times 8 minus 3 times 9. So the next one, plus 1 into 2 times 5 minus 3 times 2. So let us simplify this together. So we'll have 1, open bracket, 2 times 8 gives 16, minus 5 times 9 gives 45, minus 7, open bracket, 2 times 8 gives 16, minus 3 times 9 gives 27, plus 1, 2 times 5 gives 10, minus 3 times 2 gives 6. So let us simplify again. So now 16 minus 45 gives negative 29. Now negative 7 into 16 minus 27 gives negative 11. Wow. Plus 1, open brackets, 10 minus 6 just gives a 4. So we have negative 29, negative 7 times negative 11 gives positive 77. 1 times 4 gives plus 4. So let us simplify this. We'll have, let me get my calculator. So I'm going to have 77 is 4 minus 29. So all of this gives 52. So that is how you find the determinant of a 3 by 3 matrix. So you can just say somewhere your determinant of A equals 52. So that is all about determinant of matrices. All right, so now that you are familiar with matrices and determinants, the next thing we are going to look at is Cramer's rule. Now, what exactly is Cramer's rule? Cramer's rule is a method that is used to solve simultaneous linear equations using matrices. Now, so let's say we have an example of an equation like this. Let's say we have 2x plus 3y equals 13, and we have 5x plus 2y equals 16. We're now asked, solve for x and y. Now, we are about to use Cramer's rule to solve this. Now, the very first step you have to take is to convert this set of equations into matrices. Now, let's do that together. So we'll have, open the brackets. So we are going to have, now, we have 2x plus 3y equals 13 here. So now to turn your equations into matrices, you have to use their coefficients. Now, what's the coefficient of x here? We have 2. Write down the coefficient of x here too, which is 5. The coefficient of y here is 3. While the coefficient of y here is what? 2. Now you have converted this into a matrix. Now beside it you have your x and your y. Now if you multiply this together, you're going to get your equations back. So now using the method of multiplication, so equals to 13 and 16. So we have successfully converted our equation into matrices. So now the next step is to find the determinant of the matrix. So find the determinant. Let's say this is matrix A. Let's call this matrix A. Let's call this B. And let's call this C. This is matrix A, this is matrix B, this is matrix C. So the next step is to find the determinant of matrix A. So the determinant of matrix A will be equals to delta. So we're going to represent determinant of A with delta. So delta is equal to, we have 2, 3, 5, and 2. So the first step is to what? Convert this into an equation, into a matrix. And the next step is to what? Find the determinant of this matrix itself. So, like we did in the previous examples under 2 by 2 determinants, multiply the elements and the principal diagonal together first. So we are going to have 2 times 2 minus, this times this, minus 5 times 3. Remember, elements and principal diagonal, multiply them together first. 2 times 2 minus 5 times 3. So 2 times 2 gives what? 4. Minus 5 times 3 gives what? 15. So this gives negative 11. So my delta equals to negative 11. Now, we have found the determinant. Remember, the first step is convert it to a matrix. Next step, solve the determinant of the matrix. Now, the next step is to find delta 1. Now, what is delta 1? Delta 1 is simply you replacing the first column of this matrix with the matrix C. This is the matrix C. So delta 1 is simply you finding the determinant of the matrix after you've replaced the first column with this. So we are going to replace this column here with this. So we now have 13, 16, 13, 16. Remember, we replaced this with this. So we now have 3 and 2. This will remain unchanged. So you also find the determinant. Delta 1 equals this times this. That is 13 times 2 minus 16 times 3. So my delta 1 equals 26 minus 48. So my delta 1 equals equals negative 22. Now we have found delta 1. The next step is to find your delta 2. So your delta 2 is simply you replacing this second column with this matrix C. You know delta 1 was to replace the column here with this. Delta 2 will now be to replace this one with this. So we now have, now this would remain the same. So we'll have 2, 5, while this will change. Will now become 13 and 16. So we're going to find the determinant of that 2 to be equals to, this time this gives what? 2 times 16 minus 5 times 13. So delta 2 equals 32 minus, this gives 75. So it's 65. Yeah. So delta 2 equals negative 33. So now, but the question was to find the value of our x and y. And we just solved for delta, delta, delta. How do I get my x and y from this? Now, the formula for x and y. So the formula for x is equal to delta 1 over delta, while formula for y is delta 2 over delta. So our delta 1, we got negative 22. Divided by also our delta, we got negative 11. So this takes this. So 11 here, this gives what? 2. So my x is equal to 2. So let's find for y2. Delta y equals to delta 2 over delta. So that is equals to negative 33 divided by negative 11. This cancels this. So we're going to have 3. So y equals to what? 3. So my x is equal to 2. My y equals 3. So we have successfully solved this set of equations using Cramer's rule. So to check if you are actually correct, you can slot in your values inside any of the equations you want. You can use equation 1 or equation 2. So this is our equation 1, this is our equation what? Equation 2. So let us put it in equation 1. So equation 1 says 2x plus 3y is equal to 13. Let us put the values of x and y inside. So we have 2 open bracket 2 plus 3 open bracket 3. 2 times 2 gives 4. 3 times 3 gives 9. So 9 plus 4 equals 13. We were correct. So that is all about matrices and determinants. See you guys in the next video, and don't forget, if this video helped you a lot, you can leave a like, comment on the video or the topic you'd like to see next, and don't forget to subscribe. See you next time.